Hi everyone, it's Lasky from Malfine Labs channel, and today I wanted to discuss a little bit about the Flare Challenge 8 and also show you a solution to the first challenge from Flare 7 from last year. So let's dive deeply into this. This will be a shorter, really quick movie to just show you this. So the Flare Challenge 8 was just announced on the Twitter. It's in hex, so, but if you translate it in Cyberchef or anywhere, you can see the message. Flare Challenge 8 will start at 11 of September of 2021. You can also, if you go to their page flareon.com, you can see the same message. The Flare Challenge will begin on 11 September 2021. It's actually 28 days, 20 hours from now. And for people who don't know, the Flare Challenge is a reverse engineering challenge that is being held annually by the Flare team. Flare team is a reverse engineering team in Mandiant taking care of reversing engineering malware and things like this. And every year they held this challenge where you have, I believe, always 11 challenges. Each challenge is progressively more difficult, and each year only a few hundred people manages to solve all the challenges. Last year I think was 200, according to their page, this was 260 people managing to solve all the challenges. And it's quite interesting. The CTF takes a little bit longer than the normal weekend CTF. I believe you have around a month or 3 weeks to solve all the challenges. Mostly the challenges are like reverse engineering challenges related to malware and things like this. So quite interesting. I participated in this CTF in 2018 and 2019, but didn't have much time, and I only solved I think 3 or 4 first challenges, so not that good. This year I was planning to put a little bit more time into this, and also for preparation I was planning to solve the challenges from last year. So if you go to the FireEye blog, I will link this in the description below as well as their page. So if you go there, they actually release the solutions to all the challenges from last year, and also the challenges can be downloaded from their site, so you can try to solve the challenges from last year, and if you don't know how to solve, you can check the solution. So it's quite good to prepare for this year competition. So this is what I wanted to do, and to give me slightly bit more of motivation and to share the knowledge with you, as well I will record this and share on my channel. So I've already downloaded the Flare 7 challenges. It's a zip file here, and I think we will just quickly deep dive into the first challenge, which is called the Fiddler. So the description of the challenge is: welcome to the 7th Flare Challenge. This is a simple game, win it by any means necessary, and the victory screen will reveal the flag. Enter the flag here on this site to score and move to the next level. This is of course during the competition. Right now we just need to get a flag, and that's it. This challenge is written in Python and is distributed as a runnable executable and matching source code for your convenience. You can run the source code directly on any Python platform with Pygame if you prefer. So basically the goal is to reverse engineer the game and win the game itself. So if we open the game, there's not much here because we need to provide the password. And we can try anything. If we provide the incorrect password, it says you done goofed, don't pirate this game, and the FBI logo and everything. So yeah, we cannot play the game. So we also have source code, so that's nice, and so we will probably need to look into the source code first to see how to win this game. So you can see the source code's not that long, only 250 lines of code. So the first thing we see directly after opening is already a password check, and there's like a altered key password hip2, which we can try to provide, but that's actually not a good password, even though I had caps lock, but even if we provide the lowercase, it's still the same. So the password is incorrect, because in fact if you look further, actually the real key is a modification of this word. So what we can do here is very easy. Just open Python interpreter, just copy these 2 lines, and we can easily see that the key is ghost. So we can try this one. And we enter the game, which is a great success. And it says click on Kitty to send her out to catch mice to earn money, earn about 100 billion coins to win and reveal the flag. So if we click the kitty, we earn the money, and of course 100 billion clicks, it could be really annoying, but you can also buy auto clickers for 10 coins each. So we have 40 coins now, we can buy 4 auto clickers and it will click for us, and as you can see, it's every second it buys us 4 coins. So after some time we can buy another 4 clickers, and then it's incrementing much faster, and we can buy another and another, and to be honest, you can even win the game and get the flag just by buying auto clickers. It takes around 10 minutes to buy enough auto clickers to get this 100 billion coins, because it's an exponential increase. So, but since this is the reverse engineering challenge, we can also look at the source code and see how we can get the flag without actually having to just buy the auto clickers and spend time on playing the game. So we have a main function that's basically checking our password, and then going to this game screen function, and there's plenty of thing going on here, but what we are interested in is the victory screen. And you can see that the victory screen is supposed to give us a flag, and for this it's actually using the decode flag function. So this function has some encoded flag, and it's it decodes it to the decoded value and gives us a flag, but it also has some initial value called frop. So without knowing this value, we won't be able to just decode the flag. So we need to know this value first. So if we go back, we can see that the victory screen is calling this decode flag function with something called token as a parameter, and the token is the argument that was passed to the victory screen itself. So if we find it here, it's actually in our game screen code. You can see that we have a target amount of coins, and if current coins are bigger than the target amount minus 2 to power of 20, then it's basically just decreasing it by it until it's in the correct amount. So I believe this is some kind of a check to if our clickers buy too much coins. Anyway, we can reverse this algorithm quite easily. So if we go back to our Python, we want to implement our decode flag function. So let's just copy paste this. I will remove this lines to avoid problems with copy pasting, and we have this decode flag in our Python interpreter, and now what we need to do is basically invoke it with a correct parameter. So let's go back to our code. So we know the target amount is this. So the target amount is this number, and we also know that the current coins must be lower than the target amount minus this. So minus 2 to the power of 20. So actually, let's call our variable coins must be this. And this is our target number, and then we can see that if this is true, then the victory screen is function is being invoked with the current coins divided by 10 to power 8 and rounded into the integer. So basically, actually our variable named coins, not current coins, if we divide it by 10 to power of 8, we can see it's 1030 something 7 point something, but if we use the integer function on it, it just runs it to the integer, which is 1030. And we know from the victory screen function that the token is pasted directly without any modification to the decode flag function. So actually what we want to do is just call decode flag function with our decoded token number, which is 1030, and if we do this, it will give us the flag, which is, I can assure you, the same flag that we would get if we pass this game just by clicking. So this flag would work on the normal challenge, and this is the solution to the first challenge. So you can either do it manually just by clicking on the kitty, just need to reverse the password check first, or just reverse engineer the flag decode, the flag decoding function, and then get a flag from here. So the first challenge is quite easy. As you can see, it's usually like this on the Fiddler challenges. So every next challenge is increasingly more difficult. So I hope to get the solutions for next challenges and show it to you on this channel. So stay with me, and see you on the next movie.